right now. All right, let's go. I'm feeling mighty purple. The degree of polynomials is the greatest sum of exponents of variables in any one term. Whew! That's a really lot of words to say something that's actually very simple to see. 3x squared. That's a term. The variable has an exponent. It's a 2. So that is a degree 2 polynomial. That's it. 3xy. What is the exponent with that x? 1. And the exponent with that y is 1. The sum of 1 and 1 is 2. So this is a second degree again. Everybody cool? 3xyz squared plus 2xyz. What degree is that? Say it loud and proud, Jordy. Fourth degree. Y? 1, 1, 2. That's 4. Everybody cool? Yep. Easy peasy lemon squeezy. If there's no variables, does it have a degree? No. Why not? Because there's no variables. The degree is based on the variables.
Well, I mean, wouldn't it have a 0 degree?
0 is nothing, right? So it's got no degree. Everybody good? And then this, I'm not making you write it down. What it technically means is we like to write our polynomials in alphabetical order with the highest degree of the first letter first. Here is what I mean. I'm only showing you this once because I don't care. All right? I don't care if you actually do this way. 3x squared y cubed plus 2xy plus 3y squared. That is in proper order because x is before y in the alphabet. X squared is bigger than x. And we would finish all the x's first. Anything that has an x in it would go before anything that's just a y. But I don't care. Okay? I really don't. Everybody cool? All right. We are also not going to be breaking out algebra tiles. But we are going to draw it. There's a reason I like to draw these, not to confuse you, and it will not affect your grade if you have trouble with drawing these, because of course we are in a math class, and if you can do the work with numbers, I am more than happy. This is not, again, like grade 5, when Mrs. Bad Crumble said you're not moving on until you can show me 8 different ways to multiply something. If you know that 8 times 2 is 16, that should be enough. But that's not enough in grade 5. So we are going to actually draw this. Before we draw this, I need to remind you of a couple of things. That symbol equals 1. That symbol equals -1. This symbol, because if you look carefully, you will notice that this 1, 2, 3, it's not quite 4 long, is it?
No.
And since it's not quite 4 long, you don't know how long this is. When you don't know something in math, what does it get? A variable. So, of course, this is negative x. And then, of course, if I go all the way down one side and I go the same amount out this way, what have I made? An x squared. And what if I color that in? Negative x squared. Now, these are really useful for about 3 things in all of math. They stop being useful in about grade 9, because in about grade 9, we start talking about exponents bigger than 2, and there's no way to draw that. Okay? Now, I've seen some math textbooks that draw different sizes and shapes of blocks. So, like, this is an X, and then they draw this in a different color, slightly smaller, and they call that Y. I don't know if any of you have seen that. I just go away. All right? All right. The reason I show you this is, like I said, it shows I can think of one thing that it really helps, and it is this. Not absidy. It is this. Y 3 minus 4 equals 7. I find algebra tiles are the only way to show that, to show you why this is true. And it's very simple. There's 3, right? What does take away mean? Damn it. What does that symbol mean? Take away. And it says take away negative 4. Are there any negatives here to take away? No, there isn't. But how much is that? 1 and a negative 1. How much is that? 0. How much is that? How much is that? How much is that? So now I have 1, 2, 3, plus 0, plus 0, plus 0, plus 0, right? Now, can I take away negative 4? And I'm left with 7. That's why that works. That's about the best use I can find for these. But I'm supposed to show it to you, so I do. What does this say in English? If you were reading that mathematical sentence to me, how would you read it? 5 times x plus 1, right? Okay, so x plus 1. How many of them do we need? 5. 2, 3, 4, 5. And what's the answer? How many x's are there? 5 x's. How many 1's are there? 5. Done. The other use these have is for showing you the beginnings of simplifying polynomials, which you may know from your 9th grade class, depending on who taught you, as factoring. If you can make your polynomial, which, by the way, is this a mono or a binomial or a trinomial? This is kind of tricky. As I've written this, what is it? It's a monomial, isn't it? Because what do brackets do? What do brackets do in math? What is their purpose? Raj? They separate or group together, yes? This, however, is a binomial, isn't it? All right. If you can shape your polynomial into a rectangle, this was our answer, wasn't it? What do we call an answer in multiplication? A product. What do we call the two things that multiply together to make a product? Abner? I didn't hear you. Okay. What are factors? So up here are our factors. And product, factor, factors. Okay? If you can get your product into a rectangle, you can always see the factors because they're on the side. There is x plus 1. There is 1, 2, 3, 4, 5. 5 and x plus 1. Everyone's cool with this, yes? How many grade 9s saw this? Excellent. Algebraically, this is what me, Mr. DeVries, and the rest of the math world care about. All right? They don't care if you can draw it, because drawing it is only good up to a maximum exponent size of what? 2. Have we done exponents bigger than 2? So, you need to be able to do this way more than you need to be able to draw them. And again, we started with this, and you told me that this was in English 5 times x plus 1, right? Okay, so what this means is I have to do 5 times x plus, in English, what's a way you would explain that with words? Combined? What else could we use? Add? What else could we use? I'm not saying those two are wrong. I'm just saying there's lots of things we could say. Bring together. And then. There's a million things we could say here, yes? So, 5 times x, and then whatever, blah, blah, blah. So it's not really plus 1. It's really plus 5 times 1. Right? So technically what is happening here, I have 5 times x. Here we go. Time for the Brooklyn Nine-Nine gag.
Let's go.
Finish my password. What I really have there, of course, is 5 times x and then 5 times 1, which gets me, it's because I got to turn this on again. Cancel. 5x plus 5. Now, what is happening there is called the distributive property. A great many teachers before me have fun little names for this. All of you know I do not do fun little names. I do not tell you fun little stories. I do not say that this bracket is a wall and this 5 is trying to storm into the castle. I don't do any of that horse crap. You know why? Because when you go on further and you're all in pre-dip, you're all planning to go somewhere, educationally speaking, don't go to your first year university math class and talk about storming the castle. Okay? Because your prof will say, what the hell are you talking about? And your prof will say, oh, you mean the distributive property? And right away think you're a numpty. Okay? Okay. So the distributive property is this. A x plus y equals a times x plus a times y. How long will that go on? As many times as I need to. So if it was a x plus y plus z, then I'd have ax, ay, az. Right? Okay. Now, as I was saying, a lot of times teachers say they draw these little arrows and they give it a fun little name. If you want to draw the arrows, draw the arrows. I will not penalize you for it. As a matter of fact, sometimes polynomials get so big that you want to draw the arrows. Right? And if you're going to, that's fine. If the polynomial gets complicated, you will want to draw those arrows. Right? Right. Show a picture and an algebra solution for this. Picture goes on this side. Yes? Pardon me? Yeah, but I don't talk about it as FOIL either. Because that only helps if it's binomial times a binomial. I will say it once because all of you have heard the acronym FOIL, and then I will never say it again. As a picture, are these factors or a product? How do you know they're factors, Vicky? Because you don't know the answer. Even though you know the answer because you've already done it in your head. But let's pretend it's complicated, because if you can do the easy stuff on paper, the complicated stuff is no different, is it? But if you do all the easy stuff in your head and never write anything down, then when you get to the complicated stuff, you're all like, and I don't want you to be all like, I want you to be all like, yeah. Okay. So, factors go where in our rectangle? Inside or outside? Outside. X and 1x, 2x, then 1, 2, 3, 4. And they're all negative. And then we just fill it in. I went x that way, but I also stretched that way to make what? X squared, and then I did it again. And then I had negative here, and then I stretched it in what direction? Come on. Oh, I can't do it. I stretched it out. And what wins? Negative. And I get an answer of 1, 2, 2x squareds, and negative 4x's. Right? And if I'm doing it algebraically, again, you would never write this out this way because it's so simple if we were really doing this. But because we're at the teaching part of things, that is x times 2x minus x times 4. And I get 2x squared minus 4x. Ya, ya? Ya, ya, ya. How would this differ?
Could you scroll up for a second?
Of course I can. Is this different in any way? No, of course not. I'm not even going to make you draw the picture. But instead of 1x on the side, what am I going to have? 3 bars. So 3x times x plus 2. What's that really? 3x times x plus 3x times 2, which is really 3x squared plus 6x. Right? Right. Now, if you can do that, which every one of you can do in your head easily, you now can do all polynomial expansion, because it's all the same thing. Are those factors or a product? Factors, which means they would go where on our drawing? On the outside. X, 1, 2, 3. X, 1, 2. And then I fill it in. X squared, 1, 2, 3 x's, 4 x's, 5 x's, 1, 2, 3, 4, 5, 6. Right? Okay. And algebraically, this is what Taj was saying. This is what you people call FOIL. I don't call it FOIL because, again, it only works for binomial times a binomial. I call it what it is, distribution. So, if I had this, Could you do that in your sleep? What is it? X squared plus 2x, right? But I also have 3. That should have been a different color, dummy head. 3x plus 2. What's that? 3x plus 6. Why did I slide this 3x over here? What have I done now to make my life much easier? What have I done right there? I've lined up my like terms. So now my answer is, of course, there's nothing there. So that is x squared and nothing. X squared. 2x's plus 3x's, 5x's, nothing plus 6, 6. Now, there's another little trick that we can do there. So this is the algebraic part. Right? Everybody can do it. This is what's really happening. You people might know it as FOIL, as I was saying, so I'm going to rewrite it here. X plus 3, x plus 2, and FOIL. FOIL stands for first, which you all already know. First thing you see times the first thing you see, blue. O stands for outside, which is the outside thing you see and the next outside thing you see. Now you can see how this won't help if I have bigger polynomials, right? That's the green line. Red line, inside. So now I do the two inside things, and then a black line last. Everybody loves FOIL. They love saying, ooh, first outside, inside, last. Yay! Except, what if I had where's the outsides? Where's the insides? Where's the last? Right? So, if you know the word FOIL, you love the word FOIL, great, use it, but it only works for binomial expansion. Otherwise, you have to know these arrows. Everybody understand? But if you know the regular distributive property, you know how that works. Because, of course, this is x times those 3, and then it's 6 times those 3. What if I had 3 things out here? What if I had this? Then what would it be? Mantaj? You do that thrice, then you do that thrice, then you do that thrice, and you would collect your like terms. What if it was 4 and 4? Then you do it 4 and 4. What if it was 3 and 4? You do 3, 3, 3, 4 times each. The principle is what you need, not the fun little words. Got it? Excellent. So now, that should literally take you 2 seconds. Show me how to do it properly, and then I'll give you a gift that you already know, but I'm going to give it to you anyway. What is this properly? It is going to be first. What do I get? X squared. Outside, what do I get? Plus 4x. I'm done with x now. I'm going to scribble it out so I can't screw it up. Now, what's that? Negative x. I already have an x, so I'm going to add a negative x in a line. And then I have this, which is what? Negative 4. X squared plus what? 3x minus 4. Now, Time for the gift that you all already know.
I think it's where they don't close.
In this question, the answer was x squared plus 3x minus 4, correct? In the last one we did, it was x plus 3, x plus 2, and the answer was x squared plus 5x plus 6, right? Some of you already know this trick. 3, -1, and 4. 5, 3, and 2. Everybody good? 4, -4, -1, and 4. 6, 3, and 2. What's the gift? If I'm not going to tell you, if I gave you this without doing FOIL, what's the answer? X squared. Here's the gift. Plus 15x plus 56. What's the gift? You add these, you get the middle one, you multiply them, you get that one. But that only works if it is a single x at the beginning. So notice how I showed you that at the very, very end of everything after making you do a bunch of stuff? That's why. Because it only works sometimes. Don't stick it in your head as the way to do this. All right? Because it only works sometimes. That's what a shortcut is. It isn't how you do math. It's what you can do to speed up your math once in a while. All right. Your job today is to do page 24 and 25. I know that this says assignment. It is not for you people, because I expect you to be able to do this in your sleep. Okay? Page 24 and 25 is your homework. You can start it right now. You should have no problem getting it done. It's only 10:10. Class goes till 10:55. If you finish, I will be checking with people all the way along. If you finish, if everybody gets done, I'll show the right answers, and I will give you page 26 that is actually an assignment. This one is marked. Now, if you start on page 26 and ask me a question, I will be bothered, because that means you didn't do your practice on pages 24 and 25, for which you are going to see the right answers. Clear? In 10 minutes, I'll show you 24. That'll take 5 minutes. 10 minutes after that, I'll show you 26 or 25. That'll take probably 10 minutes. That will take us to the end of the block. Clear? Go.